to review a few housekeeping. Hello and welcome to this STMicroelectronics webinar. My name is Matthew and I will be your Global Spec moderator, and I want to review a few housekeeping items with you before we begin. Please take a moment to familiarize yourself with the operation of the user interface for today's webinar. The large window with the heading Presentation in the upper left is the primary window for today. Just to the right of the main presentation window is the Speaker Bio window with background information on today's presenter. Just below that is the Q&A window. At any time during the presentation, you can enter a question into the box in the lower section of the window and click Submit. Your question will be placed in the queue to address when we get to the Q&A session. At the bottom of your screen, you will see additional buttons to enhance your webinar experience. To see what a particular button does, just place your mouse pointer over it and a tooltip will appear with a description of the button's function. Now let me introduce today's presenter. With us today we have Dan Marino, the Staff Application Engineer for STMicroelectronics. To read more about Dan, please look at the Speaker Bio window right next to the main presentation window. And Dan, welcome to today's event. And with that, I will pass things along to you to get started.
Hello and welcome to this STMicro webinar. Today I'll be talking about NFC for simplified commissioning. Simply tap to connect to IoT devices. We'll begin by defining what commissioning is and then look into a few of the areas where it's used, including a brief overview of matter. Since the focus of this webinar is provisioning over NFC, we'll need to have a basic understanding of NFC technology before getting into commissioning over NFC and its benefits. Finally, we'll look at demos of NFC commissioning with Thread and LoRa networks. So, what is commissioning and why do we need it? In the IoT world, commissioning is the process for adding a new connectivity-enabled device on an existing network for the purpose of being able to access and control it remotely. This is typically the first step taken after a device is removed from its box. Sometimes called pairing, this process consists of two main steps: configuration of the new device and connection to a network. We're all familiar with the frustrating pairing process of a product with a limited interface. A user is typically instructed to hold button A on device 1 while pressing and holding button B for 3 seconds on device 2 and then waiting for an LED to flash to indicate something has happened. More often than not, something fails during this process, leaving the user confused, frustrated, and likely rechecking documentation to see if the pairing procedure was performed correctly. The commissioning process is quite complex, but it should be kept very simple for the end user. A poor user experience could result in abandonment of the technology. Let's face it, no consumer wants to read catalogs or dig deep into the technical aspects of pairing a smart home product. The process should be intuitive and seamless. So the challenge for product manufacturers and network stakeholders is to keep the process easy. Now, let's turn our attention to where commissioning is used and needed. First, let's discuss commissioning in industry. If we look at the evolution of industry, we see four major advancements. Industry 1.0 could be considered as the introduction of mechanization to production. This is where power generated from water or steam was used to facilitate things that typically had to be done by hand. Industry 2.0 was the beginning of mass production and assembly lines. Industry 3.0 added automation by means of computers and electronics. The fourth industrial revolution, products and the means of production can communicate, creating a real digital transformation, the industrial Internet of Things. The result is yield is improved, profit is increased, costs are decreased, and optimization is done in real time. Industry 4.0 incorporates such things as IoT, cybersecurity, autonomous machines, additive manufacturing, analytics, machine learning, and predictive maintenance, thanks to connectivity of sensors and actuators. One of the keys of IoT are sensors. These form the basic elements of real-time control and data acquisition systems. Their function is to transform physical quantities, temperature, pressure, position, into electrical signals. This allows robots on a production line to interact and adapt the production tool to the different needs, such as maintenance, market needs, or customer modifications via a wireless network. In order for this to function, a smart factory needs a means of commissioning new sensors or devices on the plant network. Now let's direct our attention to something that's a little closer to home, that is, commissioning in the home. Smart home is the evolution of home automation, bringing intelligence to our home-connected devices. Gone are the days when you had to go around all the rooms in the house to check that all the lights were off or the heating was at the right temperature. Now the management of home equipment is done centrally and remotely, from your sofa and even when you're away from home. Smart home devices include devices for lighting, security, HVAC, appliances, and energy management. The main benefit of a smart home are centralization and remote control, comfort improvement, energy savings, and security. Interest in smart home devices has been increasing. In 2022, the global smart home market has been estimated at $126 billion, growing at a compound annual growth rate of 13.3% over the 2022 to 2026 period, reflecting consumers' interest and need for connected homes. It's increasingly common for a home to have a connected thermostat, video camera, or smart bulbs. To ensure that any new device is authorized to join a smart home network, that device will need to be commissioned before being controlled remotely. This provisioning step is very important. It ensures that the new device is authentic, authorized to be part of your private network, and prevent unauthorized users from controlling it. The issue we can see today is that in a smart home, each manufacturer has its own protocol and mobile app, preventing the user to synchronize easily all his data and scenario options with all his connected devices. To overcome this issue, Matter has just been released. Matter allows communication between the devices, making them all compatible and simplified communication for the end user. Matter is a protocol application layer that provides simple and reliable device installation, ensures interoperability, and unifies the interface to interact with smart home devices. Matter is different than Thread in that it operates at the application layer, while Thread operates at the network layer. Matter is based mostly on Thread, however, it will run on Ethernet and Wi-Fi as well. The commissioning process on Thread networks is different than on Matter networks, but in both cases, NFC can ease the process. The Connectivity Standard Alliance and its 400 plus members, including major companies such as Apple, Google, Amazon, Legrand, IKEA, Philips, has released Matter in October. We've now seen that the amount of connected devices is increasing both in industrial and home networks, and why commissioning is needed so that these devices can be paired with specific networks. Let's now turn our focus on NFC and why commissioning over NFC is a unifying technology that can simplify the pairing process. The main applications for NFC, such as pairing, access control, identification, parameter settings, and customer interaction, align well for commissioning. Additionally, such benefits as short range makes it inherently secure, with additional security ability due to built-in capabilities to support secure applications. It's standardized, so interoperability is ensured. It's a technology enabler because it facilitates setup of a wireless technology. It's batteryless, so it requires no power and eliminates connectors. And finally, it's intuitive because all it requires is a simple tap. So what is NFC? NFC is short for Near Field Communication, and it's an inductively coupled wireless protocol. It consists of a reader that generates a 13.56 MHz carrier signal and a tag powered by the field generated by the reader. For communication, the reader modulates its field, which is then decoded by the tag. For communication from the tag to the reader ceases to modulate its field, and the tag produces load modulation onto the carrier signal, which is then decoded by the reader. The key takeaways are that the communication is bidirectional, and the tag side receives all its power from the reader field. A device ideally suited for NFC commissioning of a new device on an existing network is a dynamic NFC tag. A dynamic tag is an IC with two interfaces, a contactless NFC interface and a wired I2C interface to connect to a microcontroller. STMicroelectronics offers the ST25DV04KC dynamic NFC tag for this application. The device also has a 16K or 64K E2PROM memory density variants. This dynamic NFC tag connected to the main MCU would be integrated into the IoT device to help in the commissioning process. The main features of this IC are a Type 5 tag interface, which provides a good user experience in terms of read range with a smartphone, a high-speed I2C interface up to 1 MHz, a dedicated buffer of 256 bytes for fast data transfer between the RF domain and the I2C domain, a large memory density up to 64 kbits, an energy harvesting feature, and robust characteristics such as high temperature, long-time data retention compatible with industrial requirements, and a large offering of various packages for easy integration into the IoT devices. Many different networks exist today. Each has its own topology and requires different parameters to be shared before allowing a device to join a network. Regardless of the network, all share the same high-level operations. First, the device information has to be retrieved, and this can be done in many ways, including with an NFC tag. Second, the device needs to be authenticated, which would allow the device to enter the network. Third, the joining or onboarding process needs to be completed so the device can join the network. And fourth, it has to be activated once it's on the network. While somewhat simplified here, each operation contains many complex steps that are different according to the network topology and the supported protocol. For instance, a LoRa network commissioning utilizes several authentication keys. A thread network commissioning requires a commissioner, which is typically a smartphone, and Matter commissioning requires a device attestation. In any case, NFC can be part of the process to ease commissioning and thus improve the user experience. For instance, device provisioning with unique IDs and/or keys can be done using NFC. Likewise, device info needed to identify the new device can be retrieved also using NFC. Additionally, authentication is possible by exchanging keys via NFC. NFC technology has inherent benefits. It's intuitive, well-known, well-adopted, fast and simple. That makes for a better user experience. The user action is deliberate. That makes the user experience improved. This technology is standardized by NFC Forum, which ensures interoperability, so that any NFC-enabled smartphone can be used. It's batteryless. That enables commissioning operations without power, external connectors, or tactile switches. It can automatically launch a mobile app or redirection to an app store just by one tap. It's more dynamic, integrated, and robust than a QR code because of the bidirectional communication. In some cases, where BLE is used for commissioning, NFC could be used as an alternate. This would reduce the MCU complexity, as the BLE stack would not be required and likely reduce BOM costs. Moreover, an NFC interface enables further use cases in the device lifecycle, such as parameter setting, consumer engagement, and diagnostics when not connected to the network. So now let's take a look at NFC commissioning on a Thread network. Let's start with some basics. Thread is a lightning-fast, stable network technology built to improve your connected home experience. It's based upon an IPv6 networking protocol designed for low power and small data consuming devices. It uses an 802.15 independent mesh protocol. The network installation is simple, scalable, and reliable. The protocol is secure, as all communication is encrypted using AES. It's been standardized by the Thread group. The Thread network devices will speak the same language to communicate and connect together to create a reliable, self-reinforcing mesh network, rather than relying on a single connection source like Wi-Fi or Bluetooth. It's independent of other 802.15 mesh networking protocols such as Zigbee, Z-Wave, and Bluetooth LE. Thread uses some distinct terminology to describe portions of the network. A joiner is a device added by a human administrator to a commissioned Thread network. The joiner does not have network credentials. An example would be a thermostat. A commissioner is the currently elected authentication server for new Thread devices and the authorizer for providing the network credentials they require to join the network. An example of this could be a smartphone. A Thread border router is any device capable of forwarding information between a Thread network and a non-Thread network, such as Wi-Fi. It enables to use all Thread-enabled devices without any extra hub, as all products speak the same language. Some of the existing devices in your home today can become a Thread 1.3 border router once upgraded, such as a Nest Hub, Apple TV, and HomePod. Let's take a look at NFC for commissioning for a Thread device. For this demo, we need a Wi-Fi access point and a Thread border router based upon OpenThread. The border router is made with a Raspberry Pi and an STM32WB55 low-power MCU supporting Thread. The Android smartphone has a dedicated mobile app and will be used as the commissioner. The joiner device here is a thermostat emulated by an STM32WB55 board plus an ST25DV64KC dynamic NFC tag. Let's take a look at the sequence of events in order to commission a device on a Thread network. Here, both networks are linked by a border router. The first step is to get the device ID and credentials from the joiner device using NFC. The second step is the petitioning, where the smartphone requests to be the commissioner. Once allowed, the commissioner informs the border router that this device with this unique ID and password is going to request to join the network. Step 4, the joiner device starts to scan all channels and requests a connection. The Thread border router replies to the joiner device. Step 6 shows the establishment of a secure channel between both. The joiner device is now commissioned on the Thread network with a single tap only. Step 8 shows the SRP service to indicate its presence on the Wi-Fi network. SRP stands for Service Registration Protocol. It is to indicate a presence on a network. Here, this service includes the IPv6 address of the thread device visible on both networks. Thus, the smartphone can see the thread device and can exchange UDP messages to control the device. UDP stands for User Datagram Protocol. It is a transmission control protocol on the internet like TCP. To start the commissioning, we click on the thread logo on the mobile app of the smartphone and then tap the joiner device to get its unique ID and password. We can see the logo blinking during the connection. On the smartphone, we can see the sequence of steps of the process. Once the process of commissioning is finished, the logo shows the device connected and both logos stop blinking. The device is commissioned in a single tap. Now if we change the temperature on the smartphone, it changes simultaneously on the thread device. In the same way, if we change the temperature on the thread device, the smartphone displays the new temperature. Like thread, NFC can also be used for commissioning devices on a LoRa network as well. Let's look at some LoRa basics. LoRa is a long-range, low-bandwidth, low-power consumption, encrypted wide-area network. It uses a star topology and can connect many low-power, low-cost IoT devices, such as actuators and sensors. It does this through LoRa wide-area network gateways, which communicate to a network server. All the IoT devices connected to the LoRa gateway could be commissioned using NFC. Let's take a look at the demo. So the key takeaways are: commissioning over NFC allows IoT devices to connect smoothly to a network. It provides a significantly better user experience by easing the complex process of joining a device to a network. It can be applied to any network, and the ST25DV dynamic tag is the key enabler for commissioning devices over NFC. The complexity of commissioning and how to solve it are simple. Tap, connect. NFC for simplified commissioning. For more information, go to www.st.com ST25DV-I2C. Thank you for viewing this webinar.